Hello everyone. I'm going to be working on these problems for you so that you get ready for test 3. All right, so let's do these problems. Suppose you have a function, and I'm going to make it simple, okay, so that you guys can follow. Suppose you have this, and the question here is find the vertex, number 1. Number 2 is find the domain and range and graph it. Okay, so there are many options. In fact, you have 2 options, but I'm going to show you both of them. The first thing I'm going to do is I'm going to complete the square so that I will write it in standard form. And so the first thing that I'm going to do is I'm going to factor out the 2 here. And at the same time, I'm going to create a little space. Again, this is something that we did in class, but I'm just reinforcing it. Then what I need to do is that I need to write what number goes on here. And the way that I find that number is by taking the coefficient of x, which is 2, and I divide it by 2 and I square it. And that's going to give you 1. 1 squared is 1. So this number will be 1. Now at this moment I have lost equality, so I'm going to gain it back. This 1, by the way, is being multiplied by this 2. So even though you see a 1 in here, what I really added was a 2. So if I added a 2, then I need to take it away. And so now I have gain equality again, and I'm going to write this in this form. Again, to reinforce, this is something that we've done before. This trinomial here now with that additional 1 becomes automatically a perfect binomial. And so a perfect trinomial. So what that means is that I can write it in square form, x plus 1 squared. Where did I get the x from? I mean, you just write it here. This plus sign is what goes here. And this number 1 is by taking the square root of 1, this number, and the square root of 1 is 1. And then you write square. So now the vertex is -1, 3. And so I have a pretty much a clear idea what the picture is going to look like. This will be -1, and then 3, 1, 2, 3. Here's the vertex. The fact that this is positive means that the parabola is going to go up like this. And so now I can see what my range is. My range will be from 3 to infinity. My domain on all of these parabolas will always be all real numbers. Okay. So this is how you write a function that is 2 squared plus 4x plus 5 in this form, which is a lot easier, and you can actually find the vertex that way. Now, I'm also going to use the same example, but I'm going to do it in a different form, so you can see that it's the same thing. Okay, so let me write this again. This time, I'm going to find the vertex using this little formula. Okay, so the A in this example is 2, the B is 4, and the C is 5. This works whenever you have a function, a polynomial, in the form of ax squared plus bx plus c. So this is where I'm getting all this. You see the a here is 2, the b is 4, and the c is 5. Okay, so that's where I got this from. Now, I'm going to erase this because I don't need it. I need the space instead. and I'm going to find the vertex using this little formula. So the vertex then, in other words, the x value will be negative b, in this case will be negative 4, over 2 times a, which is negative 1. You see? Then what I do is to find the y entry of the vertex. So if I write the vertex like this, then I need to find the y value. And so what I do is that I evaluate it. This will be equals to f of whatever this number is. And when you do that, you're going to end up with 3. You can do the basic arithmetic, and this will be equals to 3. So you get negative 1 and 3, which is exactly the same thing that I got through this method. Okay. One thing that I left out on the first frame is that once you know what the range is and what the graph is, you can see that this point, this graph is going to have what we call an absolute minimum. And that is when the absolute minimum is at where? When y at y equals 3 and x equals negative 1. So that's when that happens, okay? So the minimum is 3. And when does it happen? When x equals negative 1. So keep in mind that in one of these exercises, there could be many questions in one. But the best way to approach it is to somehow write it in this form so that way you can answer all the questions. Again, you can do it this way also. You find the vertex, you will graph it, you will see what the range is, and then you will see whether it has a minimum or a maximum. Okay, let's do another one. Let's do another one. Let's do, let's see. Let's create one. F of x, and then we'll do 2x squared plus 16x plus 28. Okay, so quickly I'm going to factor the 2. This will be 8x, and here's my little space. I have to say that it feels weird to me to be me filming these videos without having students on the other end, but I hope that some of you will actually watch this and learn something. Okay. All right, so what do I do now? How do I create this number on the little space? Well, I take the 8, which is the coefficient of x, I divide it by 2, and I square it. This is 4 squared, which is 16. So this will be 16. So now, even though I wrote 16, don't forget that this 16 is being multiplied by the 2 here. So that basically what it means is that I added 32. So if I added 32 to regain the equality, then I need to subtract 32. So now this will be 2. This will be x plus 4 squared. And this will be minus 4. So the vertex this time will be negative 4, comma, negative 4. Here's the graph. 2, 3, 4. 1, 2, 3, 4. And again, it's going to go up. Why is it going up? Because this number is positive. And so again, this would be that we have an absolute minimum. The absolute minimum is negative 4. And when and where does it happen? It happens when x is equals to negative 4. Okay, so there you have it, another example. And you can try this also using this approach. At the end of the day, you're going to end up with the same answer. Now, domain is going to be all real numbers. The range would be from negative 4 to infinity. Don't forget that the range is from the bottom up. Okay. And that's it. Okay, now let's say that you had a case in which you had a graph like this, for instance. Okay, so this time what you have is an absolute maximum. Let's say that this y is 5 and this is -4. So the absolute maximum now is 5, and it happens when x equals -4. Okay, so in this case, the domain will still be all real numbers, but the range, since we're going from the bottom up, will be from -infinity up to, where does it stop? At 5. And we use the bracket to make sure that we include the 5. That could happen. And if this were to happen, then that will mean that the leading coefficient will be negative, something like this. That will be a case in where that graph will happen. So pay attention to that little detail, that will become handy. Okay. All right. So now I'm going to move on to something different. I'm going to do this. And it says graph the solution of this. Actually, let me do this just to keep it separated. Suppose we ask you to graph the solution of this. So the first thing you're going to do is to understand that you're not being asked to graph the function. The graph of the function, if you notice, this is going to be a parabola. If you FOIL it, you're going to end up with x squared minus 2x minus 15. Okay, that's going to be the graph of a parabola. But that's not what you're being asked to do. You're being asked to graph the portion of the graph where is below the x-axis. Why? Because anything that is less than 0, that will mean that is below the x-axis. Okay, if it was this way, then that would imply that is above the x-axis. Less than 0 means below the x-axis, greater than 0 means above the x-axis. Okay, you could also have less than or equal to. In that case, it means at the x-axis or above or below. Okay, so those cases can also happen. So the way to solve these things, again, you're not graphing the function here, you're graphing where this condition happens, is that now we're going to find critical points. And the critical points will be provided to you by doing the following. You take each of the factors and you put it equals to 0. And at each one, you end up with -3 and 5. These are my critical points. They're critical because there's a change. At those 2 points, something happens to the parabola. It either goes from being at the top, moving to the bottom, or vice versa. So then what I do is that I graph the real line, and I subdivide the real line into 3 partitions. 1, 2, 3. So I have 3 areas. The next thing I do is that I'm going to use test points. These test points have to be, each one have to be in each of the areas. So I'm going to choose 6 here. Here I'm going to choose 0. And notice that on each of them, I'm writing them in a little circle. Why am I doing that? Because I don't want to get confused. I have critical numbers on that line, and I also have test points. My test points will be circled in a nice circle. Okay. And then what I do is I'm going to check each of them. And what that I mean is I'm going to take 6 and I'm going to replace it here. and I'm going to see whether the statement that I get is true or false. All right, so here it is. When x equals 6, what happens? All right, so 6 plus 3 is 9, and 6 minus 5 is 1, plus 1. Where did I get that from? Again, I replace the 6 here, plus 3 I get 9, 6 minus 5 is 1. And then I multiply them, and then I get 9. Here's a question, is 9 less than 0? And the answer is no. So this whole area will not be part of my solution. Okay. Then I do the same for 0. When x is 0, now I end up with 3 and negative 5, which is negative 15. Now negative 15 is less than 0, so this area is yes. And when you check for 4, negative 4, you're going to end up with negative 1 and negative 9, which gives you 9, which is less. Is it less than 0? No. No. So what is my solution? How do I write my solution? My solution would be only here, not including the critical points. How do I write it? Just write negative 3, comma 5. That would be the solution of this inequality. Okay? That would be the solution. That means that that's the area where the parabola will be below the x-axis. So this parabola will be like this. And you're only interested on what is below this part. And where does it happen? It happens between negative 3 and 5. If I were to change the symbol in this direction, then I would be looking for the area where the parabola is above the x-axis. And of course, the answer will be different. The answer this time would be this area. Let me do it a different color. And the interval will be different. In that case, you're going to end up with, hold on, give me 1 second here, erase all this. In that case, will be from negative infinity up to negative 3. There's a gap now, union, and then from 5 to infinity. Again, this is if you had this instead. Do not get confused. I'm trying to give you different scenarios, but I don't want to confuse you either. Okay, so there it is. So let's do another one. This time we are provided with this. Okay, notice the difference between this one here and the previous one. What is the difference? I already had a 0 and it was already factored. So I need to make sure that I do that to this exercise. How do I do that? Well, it's just manipulation of terms. So I have the 0 and I also have less than or equal. That would imply that in this case, I'm going to end up with brackets, not just parentheses, but also brackets. Okay. Another thing that I need to do, notice that the leading coefficient is negative. Factoring that would be a little bit more complicated. So it's best to have that leading coefficient to be positive. So I'm going to multiply everything by negative 1. And when I do that, this inequality sign flips to the other way. Don't forget to do that. Be in the lookout for something like that. So now this is a lot easier to factor. Okay. Those of you who have difficulty factoring, please, for the love of God, find a way to learn factoring. So now that I'm here, it's exactly the same as this one. So what do? We're going to find the critical numbers. The first one is 1, and the second one quickly here will be 3. So now I have 1 and 3, 1 and 3. So again, when you use two critical numbers, automatically you split the real line into 3 areas, 1, 2, 3. And now we're going to check. And I'm going to write my test points in a different color. So I'm going to use 4. I'm going to use 2. And I'm going to use 0. Okay. What do I do next? I'm going to check each of them. So here I go. When x is 4, I'm going to replace it here. 4 minus 1 is 3. 4 minus 3 is 1. 3 times 3 is equals to 3. Sorry, 3 times 1 is equals to 3. And then you have to answer the question, is 3 greater than or equals to 0? And the answer is yes. So that section will be part of my solution. Then I do that with 0. I'm gonna go back to 2 in a minute, but I'm gonna do that with 0. So when x is 0, I end up with -1, -3. Is this true? Yes. And when you do 2, you could end up with 2 minus 1 is 1. 2 minus 3 is -1. When you multiply them, you get -1. I apologize, that's a garbage truck. And is this greater than or equals to 0? And the answer is no, it's not. It is not. So what is my solution? The solution will be here. We'll have a gap, and then it jumps from 3 to infinity. How do I write it? Well, let's do that. Let me erase this. How do we write it? We're going to say that the solution to this inequality, this quadratic inequality, is from -infinity up to 1, including 1. Why am I including 1? Because of this. Then there's a gap. And when there's a gap, you're going to use the symbol of U. That means union. And then when does it start again? From 3 to infinity. And that's it. You're done. Okay. So this is going to take time to digest. It's going to take practice. It's going to take a lot of scrap paper and a good pencil and a good eraser. That's what it's going to take. There's no magical pill that you can take and then all of a sudden this will be popping up in your head like a clear message. No, it's not going to happen. Okay. It's going to take a lot of practice. All right, let's do more. This time, I'm going to give you one that is not a polynomial, it's not a quadratic inequality. Instead, it's a rational inequality. And this is what it looks like. There it is. We have a single term on the left, and that's a beautiful thing. The other beautiful thing is they have a 0 on the right-hand side. That's a beautiful thing. And in this case, we may have a bracket, but the question is, where will the bracket go? Because this time we have two things to worry about. We're going to find a critical number from the numerator. This will be 5. but that's from the numerator. The other critical number, I'm going to put it in red because that's dangerous. The other critical number, let me do it here, comes from the denominator. And this guy is dangerous. We're going to put it in a triangle. And that critical number, that 6, will not contain a bracket. It will contain a parenthesis. Why? Because it's coming from the denominator, regardless of this. The reason why the 5 will have a bracket is because of this. But the 6 will not get a bracket. Instead, it will have a parenthesis no matter what, because it's coming from the denominator. So now we have 2 critical numbers, but each of them is coming from different places. One is coming from the numerator, and the other one is coming from the denominator. The one from the denominator is that we'll never get a bracket. We'll always get a parenthesis because, again, and I apologize to sound like a broken record, but I cannot emphasize the importance to know that we cannot divide by 0. Okay, so here I go. I'm going to use 6 and 5. Oh boy. Yeah, whatever. 6 and 5. Too close to comfort, but it's okay. So here's the 6. Here's the 5. Okay. This one here, I'm going to put it in a little triangle. That means danger, do not include it. And I'm going to use test points. I'm going to use 7. I'm going to use 0. And I'm going to use 5.5. Okay. Something there. All right. And then I do exactly the same that I did on the other ones. I'm going to test them. Let me start with 0. If x is 0, all I have left is going to be 5 over -6, which is negative. Okay, it's a negative number. The question is a negative number less than or equals to 0? And the answer is yes. In fact, we don't even care about the numerical value. We only care about the sign. Any number that has a negative sign is less than 0. Done. Let's do 7. When x is 7, I'm going to end up with -7 plus 5. 7 minus 6. Well, so what is this equals to? This will be -1 over 1. Again, a negative number. Is a negative number less than 0? Yes. Okay. Let's do 5.5. Let me do it in the middle. -5.5 plus 5 is -0.5. 5.5 minus 6 is negative. No, I take it back. 5.5 minus 6 is -0.5. Negative divided by negative is a +1. Why 1? Because you're dividing the same number, but it's negative divided by negative, it's +1. Is +1 less than or equals to 0? And the answer is no, it's not. So this area is no. So here comes the final step. How do we write that solution? So now, let me erase some of this stuff. Let me erase this part. All right, I think that should be enough space. All right, so pay attention to this. This 6 will have a bracket, a parenthesis. That will be this area. Okay. Gap, there's a gap there, so we use union. Now the 5, this 5, that's a critical number. And it's going to have a bracket for 2 reasons. because it comes from the numerator and it has this. So it will be from negative infinity, comma, 5 brackets. That will be the solution of this. Okay? And I agree, this is going to take practice and practice and more practice. So let's do another one. Okay, this one is more challenging, so it's going to take a lot of work. Okay. The fact that instead of a 0 you have a -2, that changes the ball game. That makes it more difficult. So the first step is to write it the way that we had this here. And that is to have a 0 on the right and a single term on the left. That's what I want to do to this one. So look what happens here. This is going to get ugly. Okay. So now I'm going to find a way. At this moment, I have 2 terms. 2 terms. I need to make it into 1 term. So I need to review what the LCD is, least common divisor. The least common divisor of these 2 fractions, 2 terms, is x minus 1. So I'm going to do some dirty work on the side first before I get to do any of the work that I've been teaching you. So I need to multiply top and bottom by the LCD. So now I'm going to have 5x plus 7 plus 2x minus 2. And I need to combine terms. So this is 7x plus 5 over x minus 1. All of this just to get to that part. Just to get to that part. So please, I ask you to review the LCD. I'm teaching 1033, and that is one of the topics that I'm covering right now. But since you are in 1105, then this is something that we expect you to know how to do. Find the least common divisor. All right, so now I'm going to be working with this here. So that's going to be 5x, 7x plus 5 over, let's see, x minus 1. And I forgot the okay, minus less than 0. This is the one. And I do exactly the same that I did to this one. Exactly the same. In this case, the critical number from the numerator, which is going to be -5 over 7, will not contain a bracket. And the denominator will not contain a bracket also. So let's do that. So the critical number from the top is 1. And from the bottom, that looks like a 7, man. Come on. It's -7, -5 over 7. So here's my line again. Here is 1, and here is -5 over 7. Now, the 1, I'm going to put it in a triangle, not to be included ever into the solution. Now, in this case, also the -5 over 7 will not be included in a solution. And the way that we do that is by using a parenthesis. All right, so now I'm going to use a different color to do the test point. I'm going to use 2. I'm going to use 0. And I'm going to use -1. Those are my test points. And I do the rest. So when x is 0, that is when my test point is 0, what do I end up with? 5 over -1, which is -5. Is -5 less than 0? Yes. 2, when x is 2. When x is 2, 7 times 2 is 14. 14 plus 5 is 19. 2 minus 1 is 1. So you end up with 19. Is 19 less than 0? No. I almost wrote yes, but it's no. No. Then I use -1, the last one, when x is -1. Third test point. So -1, -1 times 7 is -7, plus 5, -2. -1 and -1 is -2. When you add two negative numbers, turns into positive, and you get 1. Is 1 less than 0? And the answer is no. And this is no. So what is my solution? It will only be here. And so that's it. What is the answer? It will be from -5, 7, comma, up to 1, not including either of the points. Okay? So that is, we did 9 examples that relates to this. So I hope that this is helpful. Now I'm going to do something that I did for one class, but not for the other. So let's do that. This has to do with something that first looks difficult, but it's not. Let me explain. Suppose h of x is equals to x squared plus x. That's given. And then it says find f and g such that, that's st means such that, this happens. When I do the composition of these two functions in this particular order, remember what the definition of this is. This is f composed with g of x. When I do that, I end up exactly with capital H of x. In other words, I end up with exactly this. So the question is, what is it that we have to do? We have to find f and g, and we have to check it out. So here it is. First of all, the reason why you have to pay attention to this is because the order in which you write it makes a difference. And that will be provided by Alex. You don't get to decide. They will tell you the order. All you have to do is remember what that means. And what this means is that this g is going to be the inner function. All right, so we're going to work with the inner function. Remember, our job is to find f and g. Here is my g of x. Some of you may say, where did you get x squared plus x? Ah, I got it from here. That's my inner function. That's my inner function. And my outer function, which is going to be the f of x, is going to be the square root. Now, you cannot just leave that in blank. You cannot just write a square root of what? Well, we're going to put an x because this x serves as a placeholder. Placeholder to what? Well, this x will eventually be replaced by x squared plus x. And there it is. That's all you have to do. Now, if you were to check your answer and you follow this particular order, you will end up with this exact answer, which is what you wanted. They tell you what the answer is going to look like at the end, and they tell you to find, they ask you to find f and g separately, so such that when you do the composition in this particular order, then you end up with what you were given at the very beginning. This sounds crazy. It sounds like, but they're already telling me the answers. Like, yeah, they're pretty much telling you, you have the answer in front of your eyes. The only thing you have to do is decide what is the inner function, what is the outer function, and how to write it. One thing that happens a lot is students, they get this, they understand this, but it's like square root. It's like, what do I put in there? Well, first of all, don't leave it blank. That will make no sense. Again, that put an x there, because that x will serve as a placeholder, and that x will be eventually replaced by this. Okay, let's do another one. Let's do, it doesn't have to be h of x, we can call it p of x, anything. There. So that's my p of x, and this is how I want it to be done. Find g and f, notice that I'm switching the order already, such that this happens. I end up with p of x. Okay, that's what I want. Then, okay, so let's do this. First of all, I will write the definition of this. Okay, what is that equals to? This is equals to g of f of x. That's what that means. And I want this, at the end of the day, to equal p of x. All right, so now this time the f of x is going to be the inner function, and my g of x is going to be the outer. All right, all right, all right. In fact, maybe this is helpful. So what is my inner function now? Well, it's the f. But what is it going to be equals to? It's going to be equals to x plus 1. And now I need to find the g of x. The g of x will be 1 over that magical x plus x, because each of these x's will be replaced by x plus 1, and you're done. That's all you have to do. And be careful when you do this analysis. The order in which you write this matters. Do not neglect it. Do not take it for granted, because it does matter. Okay, let's do another one. Let's call it h of x again. Let's do this. Let's do something crazy. Square. Just like that. Okay? Just like that. So now find g and f such that when you do the composition, and this is critical, all of this is provided, that order is provided to you, such that this happens. Okay. Well, I know that this is equals to what? G of f of x. So that means that my inner function, once again, is f of x, and my outer is g of x. All right, so now, and so I'm sure, think about it, look at it before you do anything crazy, just develop a strategy. Look at my inner function. All of this will be my inner function. There. And my outer function will be x squared. And that's it. That's all you have to do. You don't have to solve anything. You don't have to graph anything. You don't need to know what the value of x is. That is it. You found the f and the g such that when you do the composition in this order, you end up with the original h of x. Okay, so that's pretty much it. And remember, get ready for test 3. Check the due dates, and I wish you the best, guys. And again, I sound like a crazy person talking to myself. At least that's how I feel, because I know that there's nobody at the other end. But I promise you that I did promise that I was going to send this video to you before the weekend. So here it is. Okay, so take care of yourselves. Bye-bye.